Hi, I'm Brian Cox. I am a long-term contributor to the website Scientolopedia.org. I'm also a Facebook administrator on that group. And many of you know me as the guy who interviewed Justin Craig, he's claiming to be the reincarnation of L. Ron Hubbard. What many of you don't know is I'm also trained in mechanical engineering. I got my degree as a Bachelor's of Science from the University of Washington in Seattle. And by the way, mechanical engineering is also what L. Ron Hubbard studied when he went to college last lifetime as well. Today I'm going to talk to you about what Justin has been up to since he's claimed his title as the reincarnated L. Ron Hubbard. And in particular, we're going to look at what he's put out in a book called Scientology Infinity. And in there he makes a claim that he calls the Law of Unification. The Law of Unification makes a claim about the physical universe and the mechanics of the physical universe that to a layman might seem plausible. But to anyone who's trained in physics, anybody who works in the fields of mechanics or mechanical engineering, they're immediately going to recognize this as complete hogwash. So here's what we're going to do. I'm going to show you what Justin says in his book. I'm going to give you a brief education on physics. It's really easy, I promise. It's not very difficult. And then after that, we're going to take a look at what Justin's been saying since that time, since when I first discussed this with him and tried to enlighten him about the way mechanics really work. So here we go. Here's what Justin said in his book. So here we have it, The Law of Unification by Justin Craig. He says that at any point in time where a person or an object or multiple people and objects have a mutual impact in common that has enough force to produce any pain, unconsciousness, or discomfort, there is a point, if only for a fraction of a second, where all opposing forces will equal zero and a total equilibrium or balance will occur. Okay, so that is Justin Craig's explanation for how the physical universe works. And he uses this description to explain why his processes and his technology that he's developing are effective. Now let's switch gears here for a moment, and now let's look at physics. Let's look at how physicists and mechanical engineers have been describing and understanding the physical universe for about the last 330 years. Now let's take a look at Newton's laws of physics, or Newtonian physics as it's called. First, Newton published his laws of motion in 1687, and at the time, a guy named Kepler had solved the movement of the planets in the solar system. But we didn't know why the planets moved the way they did until these fundamental laws. And these laws are so fundamental that they form the basis of every advanced mechanical machinery humanity's ever produced. Anything from robots running with the help of artificial intelligence, to advanced rockets that can take off and land so that they can be reused. All of these are built on the foundational equations, the laws of Newton. So yes, these laws are the foundation of rocket science. Now, Newton's first law of motion states that an object at rest will stay at rest, and an object in a constant motion will stay in that constant motion unless acted upon by an outside force. So both of these situations describe something called equilibrium. And equilibrium means that if you add up all the forces acting on an object, they would add up to zero. In other words, if there was a 50-pound force pushing something to the left, there would also have to be other forces that added up to 50 pounds pushing to the right for it to be in equilibrium. And then, if that is the case, and then at a later point we see that object beginning to move from rest or change its speed or direction of movement, we know an additional outside force has acted on that object. So here is an example of an object at rest. This is an equilibrium. We know that there is at least one force acting upon these books, even though they're at rest, because they have weight, and so that weight is forcing them down. But the reason that they're staying at rest is that there's an exactly equal and opposite force that's acting on them as well, and that is the shelf is pushing up on the books. Okay, so besides an equilibrium where the forces are all where the object is at rest, we also see it in objects that move at a constant speed. If you've ever played air hockey and hit a puck rather slowly, you would notice that it just basically keeps on moving at a straight line, at a straight speed, assuming you have a really balanced table. But actually, there is a small amount of friction that happens even in air hockey. So probably the best example of an equilibrium that we have where an object is moving is something that's just adrift at space. So unless some outside force acts upon an object in space that's just adrift, it's going to continue in its direction and speed of movement forever. So now let's look at Newton's second law of motion. Force equals mass times acceleration. Now when we say force, we're actually saying the sum total of all the forces acting on an object. And whichever direction those forces point as a whole, that's going to be the direction of acceleration. Now you must understand that acceleration means change in speed or direction of movement. So deceleration, you often heard that when you're braking, you're decelerating. That's actually just an acceleration in the direction opposite of the direction of motion. And any acceleration will always be applied in the direction of the sum of the total of forces. So this idea of direction is so important to understand. That's why you'll usually see physicists put a little arrow over the force and a little arrow over the acceleration to show this. And then they will usually write it as F equals ma, force equals mass times acceleration. So let's look at an example of a force causing an acceleration. If we take a ball and we just throw it straight up in the air, it's going to have an initial speed, and then we'll notice that as it rises, it actually begins to slow down, and when it gets to the top, it is slowed all the way down that it comes to a stop, and it's actually going to immediately begin to start falling. And when that fall occurs, that is going to speed up. As it comes down, it speeds up, and then when it comes back to the initial height of where you launched that ball at, it's going to have the exact same speed it had when you threw it upward. So what is happening here is a constant acceleration downward. So as it turns out, all objects accelerate at the same rate of speed because of the pull of gravity on Earth. Notice that acceleration is what slowed the ball down on its way up, and it's also what the same acceleration is what caused it to speed up on its way down. Now let's watch a video of a golf ball colliding with a steel wall. You will notice from the very first instant of contact, an extremely fast acceleration happens within the ball at some point or another. You'll see some parts of it accelerate and start to rebound before other parts, and this just has to do with the deformation of a ball. Every object, when it collides or has any force on it at all, has some amount of deformation, and that deformation stores a springiness in the ball. But you will actually notice some of these particles move upwards or downwards, and then some of them come back in, and then they come back in again. So there's an acceleration when that moves up, and there's an acceleration when it moves down. And all of this means, if you notice, you watch this over and over again, there is never an instance where no part of the ball is accelerating, ever. There is always acceleration going on inside of this ball once a collision has occurred. Now, all of this means one and only one thing. If there is always an acceleration going on in the ball, there is always a non-zero force going on in the ball. This ball, once it is colliding, is never in equilibrium. And in fact, any impact, once it makes contact, will not be in equilibrium. An impact or a collision is defined by its extreme acceleration, and therefore its extreme force that it experiences. Okay, so I have brought this up to Justin Craig directly, and he completely ignored everything I said. I then brought it up to a small group of his closest followers to try to point out that this needs to be corrected. You cannot go around making outrageous claims that disagree with science and pretend like, oh, that's just the way it is. So it's very obvious from the beginning that Justin is very ignorant about physics and how it works. And there's no crime in that. It's okay to be ignorant. But when you are ignorant and then you publish that ignorance, you're actually committing a crime against yourself. And that would be fine, and I would be totally okay with him doing that, except he's doing it in the name of L. Ron Hubbard. He is smearing the name of L. Ron Hubbard with ignorance and utter stupidity on the subject of physics. So let's take a look at what Justin said in response after I brought this up to the group to try to show him this is not right. So Justin Craig did respond to my charge that he is ignorant of physics and he is completely mischaracterizing the mechanics of the physical universe. And if you go to his website, I encourage you to look it up. It's newerascientology.com. You will find a retort that he has to my charge. And if you go there, try reading it, asking yourself, how does an equilibrium happen during an impact or a collision? And the answer you'll get from the website is Otis T. Carr built an anti-gravity machine in the 1950s. That literally is as close to an answer as you will get from reading his response. So let's look at it. Otis T. Carr. Otis T. Carr made one patent in his life, and it was for an amusement machine. And you'll see here there's a bunch of spinning magnets going on in this thing, and it somehow creates a vortex here, which I'm not really sure how it does that. But that's what it's claiming. And down here it's called Nature's Invisible Space Mechanics as used in the design of gravity generators. Now, in truth, this patent was for an amusement device, and Otis T. Carr tried to sell this as an anti-gravity ride to an amusement park. He never delivered. What happened was he dragged his feet, he wasn't showing up, and then finally on the day where he absolutely was contractually obligated to deliver, he was sick and he disappeared, but the law did catch up with him, and he ended up spending part of a 14-year sentence in jail. So that's Otis T. Carr. I'm not sure what this has to do with the mechanics of a collision, but that is Justin's response to all of this. So here's where I'm at on all this. At first, I was really angry because I felt like, God, if this is Ron Hubbard, he should have gone back to school and got an education before he started talking about all this stuff like he did last time. Last time around, he understood physics. He understood mechanical engineering and all of the mechanics involved in collisions. And this time, he did none of that. But then I stop and I realize something. I'm in a very strange position that I have to remind the supposed reincarnation of L. Ron Hubbard that when you want to find out something about a subject, you should thoroughly investigate as many sources as you can. You should read multiple books by different people about physics. You should be curious about it and be engaged in it. I'm also in the weird position of having to explain to the supposed reincarnated L. Ron Hubbard that when you look to an expert on a topic, you look to a person who is productive, who gets things done, who actually has results. You don't look to someone like Otis T. Carr, who spent time in jail and produced absolutely no tangible results at all. It's embarrassing. It is a crime against L. Ron Hubbard. It is a crime against Scientology. And Justin, it needs to stop.